Okay, in this part of the tutorial, I want to cover the computational framework, a little bit of the tools that we're using to do research in CompMusic, and in particular in Jingju music. So I will talk about the research corpus and test datasets, how we have been thinking and compiling the idea of what data to start from. And then I will mention Essentia, which is a library of audio analysis that we are using extensively. Then I will talk about MusicBrainz, which is a web site that we use to store all the metadata of the music that we are studying. And finally, I want to briefly mention Dunya, which is this prototype that we are developing and we are putting everything into so that we can evaluate and see how the kind of technologies we do can be of use. So let's start with the concept of research corpus. The concept of corpora or corpus of course has different meanings. It depends of in the area of research that we're dealing with. So I want to make sure that we establish what we mean by research corpus within CompMusic. So if we want to study a music repertoire like Jingju music, we develop a research corpus that is a subset of the Jingju music data or the Jingju music world, and basically is a collection of data that is representative of the different aspects of Jingju music and is representative for the type of problems we want to work with. So for us, again, a research corpus is a data set that can be used to study a given phenomena or a given music tradition, in this case of Jingju music. This research corpus can change, evolves as we have more data, as we incorporate new recordings, or as we know more about the repertoire, we can keep increasing this data set. And a data set is something else. So we talk about test data sets, and test data sets are specific for a research task. For a research issue that we're working on, and therefore is a way to calibrate the tools and algorithms that are developed for a particular problem. Therefore, these are fixed. These, when we publish an article, we work with a test data set. This has to be reproducible, so we freeze that data set so other people can reproduce this research. And these data sets can be outside the research corpus. We can take some other data of Jingju music that might be of relevance for that particular problem and that are outside this research corpus. Even these data sets, apart from being outside, they can also be even outside the Jingju music. So sometimes we need to generate some test data. We can generate like artificial synthesized data that can be used to measure, to have as ground truth, or to test the algorithms that we are working on. Okay? So this is basically the two basic concepts we're working on, the idea of research corpus and the idea of test data sets as the types of data we work with. And for the case of Jingju music, this is some example of what we have been collecting. So we start from audio recordings. This, as I said, our research is very much audio driven. That means that the core of the corpus are the recordings of arias in this case. So we want to study arias of Jingju music. Therefore, the collection that we bought and we are putting together and studying is a collection of CDs that include arias. So these are 113 audio CDs, and they include 653 arias total. But this is only one part of the corpus. Together with the audio recordings, we are storing and collecting data, like all the metadata associated with the recordings. So in this case, normally it's the editorial metadata that is included in the cover of the recordings and that we store in MusicBrainz, and I will talk about that briefly a little bit later. Also, we want to study the scores. We want to study the symbolic representation of this music. So we have been compiling the scores of arias, not of all, because we still have not been able to collect them all, but we have quite a few. We have the scores for 317 arias. We have them in paper, so a big effort will be to convert them into a machine-readable form, but hopefully the corpus will include the machine-readable versions of these scores. And finally, also an important part of the corpus are the audio features. So from the audio recordings, we extract some low-level audio features that are also the starting point for a lot of our research. So we collect and we store the audio features, and these we normally do it with Essentia, which is this library that I will be talking. So these also we consider part of the corpus because it's kind of the starting point of a lot of the research we do. And if we do a little bit some details over the data that we have, especially of the recordings, this is a table that expresses the different number of recordings according to different concepts. And Rafael mentioned about the role types as sort of an essential way of describing or of classifying the different types of arias. So we have been collecting recordings for the different, the major role types. And here is the number of singers we have for every role type. And then also Rafael mentioned about the Shenxians, the different melodic frameworks that are being used in Beijing Opera. The two main ones, the Shipi and Huang, which are the ones that we are focusing on. And these are the number of recordings that we have on every of these Shenxians for every role type. And these are the total. So this is not the complete set of arias recordings that we have, but these are the ones that relate to these categories that are the ones that we are starting and we are focusing on. Okay, so this would be kind of a description of some aspects of the corpus. And then about the data sets, what we're doing is putting together data sets to study some particular research problems. So for example, we are studying percussion patterns, and Ajay later on will talk about these, of how we have been studying the percussion patterns of Jingju music. And for example, this is a data set that we put together to study the different instruments. No? So these are the different the instruments of the instrument accompaniment, and we have been developing some training and test the data sets. So the training were sort of very carefully labeled so that we can train our algorithms on, and then the test data sets are the ones that we use for evaluating our algorithms. So this is a test data set that is available from the CompMusic website, and this in fact is sections of the recordings of the corpus. On another data set that we have is these patterns that we are also have been working on, and again they are all available from the CompMusic website, and these are different patterns that we have been studying, and this is the number of instances of these patterns that again we have been labeling, and these labels are all available in the dataset, so you can find these patterns in the original recordings and reproduce this work. And again, later on, we will be talking about that, and Ajay will be describing some of the research we have been doing on this. Okay, so this is about the idea of corpus and the idea of data sets that we have been putting together to study Xinju music. And now I want to talk just briefly about Essentia. Essentia is a library that we have been developing at the MPG for quite a long time, that has been growing and has been incorporating quite a number of algorithms that have been the result of different research PhD theses or research projects that we have been doing over the years. And so basically it's an extensible and reusable collection of algorithms to extract descriptors from audio. The core of it is C++, so that is quite efficient. But there is a Python binding, so there is a wrapper on Python that makes it quite easy to interact with and develop then new algorithms based on these core C++ functions. And everything is released under this open license, the GPL license. So anyone can use it, and it's available online. It's also available under proprietary license, so for people that want to embed it into some particular closed type of system, we can also distribute it in another type of license. Essentia, for the part of similarity and handling large collections of recordings, we also have this Gaia, which is a library that allows to play around with different similarity measures and classification strategies that can be used for research. And everything is available on this website, so I would encourage you to look there, and you will see a lot of the documentation about the Essentia library. Just very briefly about the kind of things that Essentia has. One of the fundamental aspects is all the audio I/O. When we deal with large collections of audio, there's a whole bunch of different file formats that audio has. So we have been developing a way to standardize all that, so that you can make sure that you deal with the sounds in the unified way. So it converts automatically any type of file format into a standard one used internally by the library. And there is a whole bunch of standard DSP type of tools that allows to do like equalization or some other type of filtering that is quite useful before actually running some of the core algorithms that we have, which are basically these type of ones. So descriptors, audio descriptors that relate with different aspects of music, like spectral-based descriptors or time domain and rhythmic descriptors or tonal descriptors or more high-level descriptors. And again, this is just some concepts, some examples of that, but there is many, many more. And later on, again, Jay and Sankalp will talk a little bit about some of these descriptors and how they can be used to analyze Xinju music. And one of the nice things about Essentia is that basically it's a framework. It's not just a collection of algorithms, but it's a framework that allows to combine these algorithms quite efficiently. And then you can develop your own extractors. No? So the idea of extractor is the key concept of putting together a whole bunch of modules to perform a particular task. So for example, this is an example of extracting the key of a piece of music that is based on combining sequentially different modules of Essentia, so that from the audio input you can obtain a label that is the key of a piece of music. And Essentia is not independent of other libraries, so it uses some external libraries for some tasks, like for example for the FFT that uses FFTW, or for the I/O and conversion of formats that it uses the FFmpeg for that, or for resampling, or for different ways of handling metadata or the output file formats, etc., etc. So these are some external libraries that Essentia uses. Okay, so that was Essentia. The next thing I wanted to mention is about MusicBrainz. MusicBrainz is basically a website online. It's a database of information that could be said that is an open music encyclopedia that, based from a crowdsourced type of approach, it gathers and shares metadata related to music. Mainly it's about the editorial metadata related to commercial audio recordings. And apart from this idea of collecting information and making it available, one core aspect of this is the idea of having what is in the website mentioned is like a universal lingua franca for music, in the sense of having very unambiguous ways of identifying entities or concepts of music. So it assigns identifiers to every particular entity that it includes. So that's an excellent way to refer to a particular recording that might be expressed in different languages or might have different spellings of a given artist, and we have a way to unambiguously describe a particular entity. So for example, these are the types of entities, each one having a particular identifier that MusicBrainz has structured. So the idea, this structuring aspect is fundamental, and it's fundamental for us. So we can have entities like is the name of the artist, or the label of a record, or the actual recording, the release, a URL even that links to an external document like Wikipedia. And another aspect of that is that these entities, we can establish relationship between entities. So we establish the relationship, for example, of an artist playing an instrument or being present in a recording, or the idea that someone composed a work. So all these relationships are excellent, and the MusicBrainz allows to establish them and then be able to access these relationships, and from an external application access all the data and the relationships that is present in MusicBrainz. And finally, I want to talk about Dunia. Dunia is again a website, a prototype that we are developing in the context of CompMusic to evaluate and demonstrate quite a bit of the work that we do. So this is the main interface of the current prototype. We still do not have the collections of, for example, of Beijing opera, and we don't have it either for the Turkish Makam and the Arab Andalusian. We just hopefully soon it will be available. Right now we have the versions for the two Indian traditions, for Carnatic and Hindustani. So this is the first page of the Carnatic collection, and the idea is that we have access to the recordings of this collection through different ways of navigating and searching the data and the metadata. So for example, here we have the main entities that in Carnatic music make sense. So artist, concert, instrument, raga, and tala. And then within that, you can do a specific queries, a specific searches to find a particular entity or a particular recording. So for example, a particular entity could be the name of a performer. So this is the page of Amrita Murali, which is a singer of Carnatic music. And in here, we gather the information we have about her. And we have data, of course, from MusicBrainz. So all the information about the recordings that she performs in, and even the cover art comes from MusicBrainz. But we also gather information from other sources, like in this case, Kucheris. That is, for example, the biography of this musician. And here we can start doing interesting things computationally, but we're not going to talk about now. But for example, here you see similar artists. So we can do some semantic analysis on the metadata of, that we have in the corpus, so that we can identify similar artists based on these relationships that we have within the corpus. And then once you go into a particular recording, so this would be one recording of a concert, and in fact in Carnatic music most of the recordings relate to concerts. So then you have access to the different tracks, the artist, and clearly then you can go in and listen to them of that. But let me just we did kind of a prototype of a possible track of Jingju music. So this would be the actual recording of one track of the CDs that we have been collecting of Jingju music, and this would be the type of representation that we now have for the other music traditions. So we have the audio recording, here we have the overall view of the audio recording and a zoom in into what we're playing now. We have some segmentation that ideally is generated automatically for identifying the meaningful segments of an aria. And then we have been extracting aspects of that. For example, the pitch contour of the main, the melody of the singer. And in here you see what we call the pitch histogram, which is a representation of basically of the overall view of the pitch information. So we can see a distribution of the pitches that the singer is singing in this particular aria. So, and well, here there is some information about the aria. We can know about the tonic or the starting note of the scale, and well, we can extract other aspects from this recording. So let's listen to that. Here we also have the lyrics of the piece. So while you listen, you can look at the lyrics of the song that are synchronized automatically. Well, hopefully that will be done automatically. It's synchronized with the pitch of the song. Okay, so hopefully that will be the version of the Jingju music within Dunya soon. So all the corpus that we have been collecting will be available and accessible through the Dunya website. And about the availability of this corpus, the corpus, not just the Jingju music, but all the corpus we are been gathering, the idea is that is all available for research, and it's available either through the Dunya browser. So you can navigate through that and get all the information, or computationally through the API. So for us, that's how we access all this information using this API, which is so this is a wrapper in Python that you can access all the information we have in the corpus, both the recordings and all the metadata that we have been gathering. And if you are interested or anyone is interested, we can easily give access to people to this information. So the audio, that's the only part that we cannot distribute it openly because it's commercial recordings, but they are easily available. In fact, all the recordings we are gathering are the recordings that are most commonly available for this type of, or for every type of music we are studying, so they're easily accessible. And for research purposes, we can also share it with people so that they can do some analysis on that. The other aspects of information that we have, they're all available freely. So all the features, all the analyses that we are doing with Essentia and with the different softwares that we are developing are available under open licenses through the Dunia API or the Dunia browser. All the editorial metadata is available in MusicBrainz. So we have been putting a lot of effort in compiling all this information, and there is several collections of these different corpus in MusicBrainz accessible. And apart from this, the corpus, there is this idea of datasets that I mentioned, and there is a lot of manual annotations in this dataset that is very valuable and very useful for research. And again, everything is publicly available through the CompMusic website. Okay, and that's all I wanted to say about the computational framework. Of course, if we go into some specific traditions, we're doing specific things that might require specific tools, but I hope that this has given you a general overview of the type of tools and the framework that we have, specific for Jingju music, but also that is available for all the other repertoires that we are studying. So, thank you.